Dear ladies and gentlemen, I'm very happy being here to share some things, insights in the context of Industry 4.0. Industry 4.0 is indeed a label which is created in Germany due to the discussions, the intensive discussions we have in the context of bringing digitalization into the companies, into the shop floor level, and to make it really as a part of our practical life. Digitalization is a thing which we are discussing since years. Since years when we're talking about components with integrated intelligence, when we are discussing about mechatronic design of integrated parts, we are discussing about things, how to combine them in the context of communication systems. And this label Industry 4.0, 4.0, it is written with IE, not with Y as you would write it in English, because it is coming from Germany. It is the result of an intensive discussion of all stakeholders which are dealing with the aspect of Industry 4.0 of industrial IoT. And to be clear into this context, industrial IoT has really a vision. Industry 4.0 has a vision of bringing intelligent production methods and components together to optimize processes with the methods and the use of digitalization, to implement cyber-physical systems as an enabler for intelligent manufacturing. It is dealing with intelligent workpieces and intelligent production processes and flexibility of processes, because we have to realize that flexibility, one-piece flow, needs to be implemented in our companies. It has to do a lot with standardized but not proprietary interfaces in the world of the digital infrastructure, and we have to design together with this a flexible and a human-oriented human-centric production. People are still being a central role in all aspects of engineering and on the shop floor level into the future. So here you can see some companies which are working together in building such a community where we are dealing with these aspects of standardization, of things which we have to bring really on the shop floor level to work, to bring Industry 4.0 really into the work of production process. Industry 4.0 is a community where we have the research partners, where we have industry with their specific demands, where we have politics, which can give us a lot of organizational help. We have the unions on board, and we have society on board, so it is a general discussion as we discuss it here into this conference as well. And Industry 4.0 has, in our opinion, 4 aspects. The first aspect is the horizontal line of integrating the different partners of the value creation chain. The second is going into the depth into the automation pyramid, covering the different levels of the ERP system, the MES system, and coming down to the control system and to the shop floor level with the sensors and actuators. We have a third thing that is the lifetime aspects of engineering. During the lifetime of a product, we are having a lot of engineering tools and things which support the engineer and which support the people with database tools and model-based tools in the different engineering tasks. And the third is making really things, thinking about what is the role of people, what is the role of men in all these aspects. And I will go through these 4 aspects with some real examples we have already on the market. But first, to state clearly, Industry 4.0 is not covering all the IoT things of the world. It is not the B2C market, the business-to-customer market. It is strongly in this context of the industrial value chain with its specific demands on reliability and safety. It is the specific demands on bringing digitalization into the companies, bringing digitalization into, onto the shop floor level, as I mentioned now several times, and it has to deal with the specific demands on safety, reliability, and security in this context, and the real-time aspects. So the technical demands which we have to solve are a little bit heavier than in other contexts. As a company, we are dealing strongly with this Industry 4.0 demands. We have just implemented a rather new factory for all our valves and valve terminals in Germany, where we can study all these aspects as a real-life test bed in real life and get experience in these highly flexible production lines. What does it mean when we modularize all these aspects? What does it mean when we are dealing with energy efficiency, overall energy efficiency of a plant? What does it mean when we are discussing reusability of parts which are now have to be integrated in another context? And what can we do in this aspect of re-education of our people? So we have a real example, a real test bed in our own company where we can implement the things of Industry 4.0 step by step and can learn from this and can improve the implementation. The first thing is the horizontal integration along the value chain. The opportunities with data for new business models is discussed here. The partners along the value chain will cooperate in a rather different way than before. We are working and we are growing together. And this is one aspect of digitalization, that the partners, the several industrial partners, are working closer together in the future than they did in history. We have new service models. We have to think about who is responsible for what part in the production line and the functionality, and who is paying the cost, in which kind of way can we do the billing in this context. We have the chances of process optimization. For example, getting real optimization tasks of, for example, optimize the overall equipment, the overall equipment, I don't know the English word, to optimize the processes on mathematical, on data-based models, which we are going to implement in parallel to the process, and then find out how we can optimize the overall process. And we can do all these things with simplified engineering processes and the predictive maintenance chances we have discussed a lot during this conference as well. For example, here we have one intelligent product which is used for optimize energy management in the different states. On the basic level, it is just important to have sensors which are able to measure what is the air consumption, for example, or what is the electrical consumption you have, and you can draw first conclusions from this. The second stage is you can use these data to control your plant, you control your facility. And the third stage is how to deal with new models coming from data processing for big data analytics and make really on a management level optimization and performance optimization decisions, with a final goal that we have a self-management of such processes due to optimization goals. The vertical integration is the next thing. Combine all the sensors, combine all the actuators with a data model to a consisting model which can be used over the different levels of the pyramid, of the, so that you can combine the signals, you can combine the sensors, you can combine the actuators with cloud and fog-based technology, so that you can have up from the different levels, basic level of the shop floor to the MRP and the ERP system of your production line. And you have to need therefore this, you need this data connectivity. You need to have the cyber-physical ability of your components, of your sensors. And this is one of the most important development tasks we are dealing there. In this step, I would like to introduce this new Festo motion terminal. It is one valve terminal with one structure, with one geometrical design, and it fulfills all different valve functionality you are using for controlling pneumatic actuators on your field level. And the different functionality is just loaded down via motion apps which provide the functionality which is finally in the final implementation step used. This is a motion terminal, this is a valve terminal which is already on the market. We have introduced it at the last Hannover Fair. The third is integrated engineering along the whole product life cycle. Engineering tools based on mathematical models, based on data models, helps you with this virtual data, bringing all the design tasks, the commissioning tasks, the implementation tasks with high-end simulation models and engineering models together, so that the engineering effort in implementing these is tremendously slowed down and reduced. For example, this customer-specific handling system with a handling guide online. There is an online tool when you are looking for a handling system, a Cartesian handling system here in this case, for a specific pick-and-place application. You just define the task, and then you get the dimension with a tool, and you can use the same model for implementation, for commissioning, and during lifetime of the whole handling system when it is going into work. And it is reducing the engineering effort and the engineering time at least 50%, and the time to market at 20 to 30 or 40%. Human centricity is the fourth column. We have heard, just in the discussion before, we have heard a lot of ideas how we can take our people with us into these training tasks. We have to implement things, and a new idea of that education is not finished when you have finished your university. Education is something which is self-understanding of a lifetime. You have to go with new things, you have to deal with new things throughout the whole life, and education is more or less a task that you train the people. How do they get the new knowledge? How do they discover knowledge gaps? And how do they have the real tools to close their knowledge gaps? That is one of the most important things. Focus on people needs to help them to develop the skills which are needed to deal with these aspects of digitalization. For this, we have, I will show here with this example, we have implemented this learning factory in the inside of our new factory in Scharnhausen, in this new built Festo factory. There, the people can go learn online during their jobs, going a little bit apart and training new things, training new demands, and go back to their working place with these new skills. This can be continued several times for their duty, so that they are, every time they are at the top level of the knowledge which is used, and they are supported with a lot of training courses there. Festo, as a company in automation, stands for this general view of this idea that productivity is not only a thing of machines and systems and technical items, is together coming with people and the ability of organizations, and real productivity steps can be achieved if you bring both parts together in an optimized way. And so we are working with our 300,000 customers throughout the world. I would like finally to thank you for your attention, but with a few remarks. First of all, Industry 4.0, in my opinion, is a revolution, but which takes place with an evolution type of change. It is not jumping over a large, big gap, and you do not know how to jump over it. It's just more a procedure like going step by step as you need it when you climb up a hill. Might be that it is a steep hill, but you have to just go step by step. And I would like to encourage you just to go into this direction, step by step, dealing with these aspects of digitalization throughout the whole processes of your company. Thank you very much for your attention.
While we're waiting for the PowerPoint to come up, I'd just like to thank the organizers for the invitation to be here. It's my first visit to Brazil, in fact, to any part of South America, and I'm having a wonderful time. I happen to be half Portuguese on my mother's side, although I don't have the privilege of understanding your language, so I appreciate the fact that you allow me to speak English. This has been a wonderful conference so far. The talks this morning have been really quite stimulating and really set the stage for the talk that Peter and I are giving about the role of digitalization in manufacturing. And what we're seeing here is really what we can do to use automation, the power of digitalization to transform manufacturing. So what I'd like to talk about here is really, well, there we go. Well, all right, I'm going to talk about energy efficiency in the manufacturing process and how we can use digitalization to improve energy efficiency. I want to put this in context for you. Throughout the world, we use about 549 quads of energy to power our civilization. Remind you that a quad is the energy equivalence of 8 billion gallons of gasoline. So that's quite a bit of energy used for our planet. A little over half of that energy is used on our industrial sectors. And about 70% of that, or more than a third of the total, is used for our manufacturing sector. So quite a bit of our planet's energy is used for the production of goods. And we'd like to ask ourselves, how much of that energy is efficiently used? Well, it turns out there's quite a bit of room for improvement, because nearly 42% of the energy used in manufacturing is wasted. Some of it through waste heat, which is difficult to recapture, but much of it also in terms of inefficient lighting in factories, inefficiency within the various devices within those factories, and less than optimal operations. So there's a huge opportunity here to save money, which will increase profits and productivity. And to put this 42% in context, That is enough energy to meet the power needs of Brazil for 6 years. So quite a huge opportunity for us if we can really harness energy efficiency. And after all, if you're able to be more efficient, that energy you've already paid for. So let's take the most advantage of it. Now let's look where that energy and efficiency might be arising. Well, here's a typical factory floor, which you can see here is quite a bit of lighting used in the factory. In fact, lighting throughout buildings is a major source of major opportunity for greater energy efficiency. If you go down here a little bit more, you can see a number of devices where it's very energy intensive in that factory floor. Robots, various processes, in addition to the lighting I mentioned. And so what we'd like to look at here is really the power of digitalization to help us be more efficient with those resources. So what do we mean by digitalization in this context? Well, we're talking about here is really the convergence of 3 technologies we've already heard a lot about today. Information technology, the computers, the networks, simulation, communication, those traditional technologies that we've been talking about, coupled with sensor technology, sensing the environment in which we're operating and living, gathering that data and exploiting it through information analytics. And then finally, combining that with operational technologies to run our factories or buildings more efficiently. So we're really looking at this convergence of technologies and digitalization. And what we want to do here is create a platform to make it easier for companies to harness the benefits of digitalization. And that is really the goal behind one of the new manufacturing institutes being launched in the United States. Under Manufacturing USA, a number of institutes are being launched to explore different technologies. This one, the Clean Energy Smart Manufacturing Innovation Institute, or CESMI, is really looking at how do you harness digitalization to transform manufacturing. And this happens to be a partnership involving more than 200 participants drawn from industry and academia, working together, organized around 5 regional hubs within the United States. In our laboratory, the Pacific Northwest National Laboratory, has the privilege of leading the Northwest Hub. And the goal here is to really look at how we can transform manufacturing through these technologies. And we'd like to do it at 3 different levels. The first is the single factory floor, as I showed you before. What can we do there to harness energy efficiency? Next, go beyond a single building or factory to look at an entire campus and a set of buildings. And finally, ultimately, we'd like to ask ourselves, what can we do with the entire supply chain? And so this is the focus of the Institute. And we have a number of partners. The effort's just getting off the ground. And so let me tell you some of the early stories of what we're being able to do and where we want to go. So let me take an example drawn from Praxair, and just looking to illustrate the example of a single factory or building. This one's shown in Port Arthur, Texas, one of their factories. And what they look at is really the methane steam reformer. And what they want to do is inside there is ask, what can I do to improve its operation? And so here, what they did is installed a number of sensors to gather data. They built a mathematical model of its performance, then ran a number of simulations using that data to determine how to optimize the performance. What was the result? 8% energy efficiencies savings. There's money right to the bottom line. This was so successful, they then replicated this across 19 other plants across the United States. And the next step is to look at how to do this to optimize other processes within their company. Now, this is an example within a single factory or building. Let's now look at a campus. And here we're working with Arconic, which is the R&D arm of Alcoa. And here we're looking at their campus, about 20 miles outside of Pittsburgh, Pennsylvania. And what you can see here is a number of buildings, factories, and facilities. And what they'd like to do now is optimize the operation of the entire campus. Here, we'll again use sensor data, strategically placed and collected, but now combine it with information analytics, the power of big data that we've been hearing about, brought to the factory floor, or in this case, the campus. And here the expectation is to use this to greatly improve productivity while holding energy usage constant or actually reducing it. And so this is one of the works that we'll be looking at and reporting its progress in the coming year or so. And finally, let's look at the whole supply chain. What can we do here with General Mills, a major food producer? What they want to do is look across the supply chain, across the entire United States, starting with the grain that's being grown in the fields, and asking, what can I do with sensor technology to determine the optimal irrigation for that field, application of pesticides, et cetera, so I get the optimum product out of the field before it gets to the factory. Then within the factory, using some of these other techniques, the transportation system, getting it to the warehouse, to the supermarket, and ultimately to the consumer. Here, what they really want to do, to borrow their own phrase, is to optimize operations from field to fork. And so doing, realize improved efficiencies throughout their supply chain. Now, this is an area where we want to use digitalization. A lot of work has been done in this area. We're looking to apply that through this institute. So what is Pacific Northwest National Laboratory bringing to this? We're looking at a way to accelerate this process, this convergence of these information, sensor, and operational technologies. What we want to do here is go back to our original example, looking at this with the information technology, and look at how we fuse that and make it easier for people to realize this convergence. And the technology we've invented is something we call Voltron. It's a very simple platform. I'll tell you a bit about it. And here's an example of it. You can see it up here. It's about the size of a deck of cards. And what this allows you to do is retrofit into existing facilities to realize some of these powers. What is it? It's simply a combination of a very simple, lightweight compute platform like Raspberry Pi, coupled with software that's written in the open source fashion, community effort, which we're looking at people to bring their best ideas, share in the development of this technology for a variety of applications, and make it available through the Voltron.org website. It handles a lot of the communication, the data processing, and it does so in a cyber-secure fashion, keeping your data safe. So how is this technology, which we've been developing in the context of building efficiency for other applications, relevant to manufacturing transformation? Well, here, let's go back to our schematic. What it can do for you is take that sensor data that you're collecting in your building or in your factory, bring that in, communicating not just one device, but with many devices within a single building or across an entire campus. Use information analytics to process that data. The next thing you can do is it can talk with the grid, with your grid supplier. So now what you can do is through the power of transactive energy is to allow you to negotiate the best time to run your various technologies, your various devices. Lower the demand when demand is peak so you can save energy bills, take advantage of that, and automatically negotiate that pricing. That's built into the technology platform called Voltron. And then finally, use all that information to actually optimize your operations and energy efficiency. Now, we've developed this in a different context, as I said, but let me show you some of the ideas of why we're excited about the Voltron technology and why we think it has real relevance to manufacturing. So let me give you an example here drawn from supermarkets. So what we've done with this, and colleagues actually at Oak Ridge National Laboratory partnering with us, took this device, wrote the right software to couple it into the refrigerator defrosting units that you see when you go to the supermarket. Now they have a defrost cycle, and right now that defrost cycle tends to be on. You go for a while, turns off, cycles back on a very regular pattern, whether or not the device needs to be defrosted. But increasingly, you have sensors giving environmental information about that refrigerated case. What Voltron can do is take that information and run the defrosting unit only when necessary. As you can see here, it reduces energy usage by 75%. And if implemented throughout the United States, would be equivalent to the energy used in over 200,000 homes. An even bigger potential is work that we've done with a Western Washington-based company called Transformative Wave, where they've looked at integrating Voltron into their existing products and retrofitting it into existing rooftop HVAC units. And here what they're able to do is, again, using sensor technologies, decide when you'd run the compressors, the fans, etc., what part of the building, optimize that, and again, communicating with the grid to run at the cheapest time of the day. And what they've shown in a number of experiments is a 50% reduction in your utility bill for running the HVAC. That's considerable savings. Now imagine if we took these savings and this technology from that, which is we're just looking at running buildings more efficiently, to your factory floors. And so that's why we're excited about this particular technology. We've also begun to think about it in the context of a campus. What's the campus here? This is actually Pacific Northwest National Laboratory in eastern Washington State. And what we've done is we've installed Voltron in 10 of our own buildings to manage both electricity and water usage as part of our sustainability program. And we bring all that data in, and we can monitor it through our systems engineering building and our buildings operations center. And what they're able to do here is look at that, and we're in the middle of a program now that we're implementing that we expect to be able to harness this power of mining that sensor data using information analytics to lower our electricity bill on the campus by about 20%, which is important for us because we're seeing double-digit increases in our utility bills. So what I've shown you here is really a technology that we're looking at in which we want to bring the power of the Voltron that we've demonstrated for energy efficiency to this new institute, to provide a platform that'll make it easier for businesses of all sizes to take advantage of digitalization, to lower their energy costs, eventually perhaps water costs, improve operations, and really make manufacturing much more cost efficient. And so this is one of the developments that we're working on at Pacific Northwest National Laboratory. We're one of 17 U.S. Department of Energy national laboratories working to advance energy resiliency, basic scientific discovery, and national security. So I want to thank you very much for your time and attention. Again, thank you for the invitation.